All right. Thank you all for joining us today on the Decarb Tech Series on very high efficiency HVAC. My name is Miranda Wright, and I am the Education and Engagement Manager with the Illinois Green Alliance. This education program is hosted by the Building Energy Resource Hub, a new project of Illinois Green. Today's session will focus on a specific building retrofit strategy that has been piloted on several projects in the region and across the country. We have two great speakers joining us today to discuss today's topic. But first, let me share a few logistics about today's session and share a little bit about the hub. You all have been muted upon entry, but please use the chat and QA function to share your questions for the speakers throughout today's session. At the end of the presentation, we'll have some time to ask your questions to the speakers during a short discussion time. After the program, all attendees will receive a PDF of the slide deck, recording of the session, and additional resources about today's topic, VHE HVAC. But before we jump into today's program, I'd like to take a few minutes to share more about the Building Energy Resource Hub. Next slide, thanks. Launched in August 2023, the hub was developed to serve Chicago and northeastern Illinois area with critical training and resources to ensure our region can meet aggressive climate action goals within the building sector while building an inclusive green economy. Through the hub, we are working to scale building decarbonization strategies, address market gaps, and convene and curate technical and actionable resources for the building industry, specifically for building owners, operators, developers, and contractors. Next slide. On the hub website, you'll find new industry playbooks and guidance, as well as technology primers to help support project team decisions. We'll be adding more resources and guidance in the coming months, and we encourage you to share feedback on what resources and education would be most helpful to you on our website. And here is the website. Learn more about the Hub's current resources, future education programs, and sign up to receive updates and newsletters on our newly launched website at buildinghub.energy. And now I would like to welcome our speakers for today's session. David Cohen from Institute for Market Transformation, or IMT, and Jamie Johnson from Verde Efficiency Solutions. Thank you both for speaking with us today for the Tech Series, and take it away, David.
All right, thank you, Miranda. Give me one sec. I'm gonna share my slides. Whoop. Okay, hopefully you all are seeing the cover slide. And thank you so much for taking your lunchtime to hear this presentation. Hopefully it's interesting to you and gets you excited about doing projects along these lines. So I'm going to talk about what we call very high efficiency HVAC. I'll be referring to it as VHE HVAC. And I'm going to start off by giving an overview to the approach, or the general description of it. And then Jamie is going to talk specifically about one of the buildings in Illinois that has had a system like this installed. Want to thank Commonwealth Edison, who has funded 4 demonstration sites in Illinois. And we're just starting to get them one of them's done, one of them's almost done, a couple are still in process, but over the course of the next 6 to 12 months, we should have great performance data on all of them. So thank you, ComEd. All right, let's get started here. I work for a nonprofit called the Institute for Market Transformation. We want high performance buildings. You can see our mission there. And we are always looking how to get people to get excited about doing high performance activities in their buildings. So the starting place for all this is all these goals that people have set and organizations have set, very aggressive goals, high targets and really short timelines in many cases. 2035 is not very far away. So the question, and I want to say up front, we are only talking about commercial buildings in this presentation. So let that be your framework. So the question is, now you've set these goals, right? Or your corporation has set these goals. How do you actually reach them? And I want to start from an analytical perspective. You may or may not be familiar with this. This is CBEX data from the US government. And this is a pie chart, sort of an aggregate average commercial building in the country. Where does the energy get used? And you can see space heating by far the largest. You know, obviously, if you were in Florida, it would be different, but this is an average building. So space heating is by far the biggest. And then the next biggest is other, which doesn't help you very much. You know, that's 16%, but that's a lot of little things. So programmatically, you can't do much about it. And then there's several others, lighting, but we all know we're on an LED trend on that. That slice of the pie is relatively small and getting smaller. And then the next two are ventilation and cooling. So let's talk about HVAC. When you put those three pieces together, the pie looks like this. More than half the energy is going to HVAC. And when you start talking about office buildings, retail, schools, things that do not have big cooking loads or refrigeration loads, it starts looking like this. So I am just going to say, as a matter of sort of mathematical fact, that if you have a really aggressive target for your buildings, you are not going to achieve it unless you do something awfully big with HVAC. And that's doubly true if you're talking about decarbonization, because space heating uses 85% or more, depending on the building, of the natural gas. Unless you're a laundromat, you know, where you're running water, hot water constantly, space heating is the thing. So we're back to HVAC. All right, that is why IMT as an organization cares so much about HVAC and this approach. So let's talk about where we're at now. If you have an HVAC problem right now and you call up a contractor and you say, you know, I got 4 10-ton units on my roof, what should I do? Those pictures are identical in case you're confused, because that's what you're going to get. They're going to say, oh, you got 4 10-ton units. We're going to put 4 10-ton units up just like that. All good. They are not going to ask whether there should have been 40 tons on the roof in the first place. They are not going to mess with your ventilation and make sure it's working right. They're just going to take those boxes off and put new boxes on. I'm not saying that's 100% of what happens, but I will say it's 95% plus. Like for like replacement. That's what they do. I'm going to jump now to the results of this approach that we're promoting. And the idea is I'm going to get you all excited about it, and then we're going to talk about what it actually is. So these were initial demonstration sites that were done in the Pacific Northwest. The Northwest Energy Efficiency Alliance, another nonprofit, developed this concept and demonstrated it. You will see those middle HVAC savings are 85%. The worst that happened was 43%. So the average is around 70%. I feel really safe in saying that people do not see numbers like this very often. But I would say the almost more impressive numbers are in the right-hand column. So this is whole building savings, which again really emphasizes how big a part of overall energy savings HVAC is. So we get big energy savings. This is another example. So this was an electrification project in Tarrytown, New York, 71,000 square feet, got rid of the natural gas, and the electricity use went down by 34%. And demand went down by 25%. And I'll tell you, this was a pretty poor performing building. So maybe the savings were a little better than you might think, but there are zillions of buildings like this in the country, and it wasn't out of line with results we've gotten in other places. Here's another example of how well this thing works. So you may remember in Portland, Oregon, a couple of years ago, they had this crazy heat bubble, what it was called the heat dome. And I lived in Portland for 20 years. 112 degrees is insanity there, but they got it. And a building that had installed one of these systems was operating, and it kept set point on the west wall. It kept within 2 degrees of set point on the west wall, even though it was 22 degrees above design cooling temperature. That's pretty good. The chart at the bottom is what makes it amazing. The old system was 17 tons. When they redid it with the VHE HVAC approach, they reduced that to 10 tons and still met set point. All right, on the hottest day of the century. Also, you get energy savings, you get electrification without increasing electricity use, and you get way better indoor air quality because we are going to separate out the ventilation from the heating and cooling functions, which I'll talk about in a second. These are just 2 quotes from people who liked what they got in their systems and said they could actually notice the difference. I just got another quote from the Oak Park Temple where you're going to go this afternoon if you're on the tour. The administrator there said, "I used to come to work and get headaches, and now I never do." Pretty good testimonial. All right, I do want to talk just a second more about electrification. So this is one of those demonstration buildings. You can see it started with gas heat, and then the right side is post-installation. The gas went to 0 because, of course, it's electrified, but this is the part you care about. The electricity use barely budged. That just doesn't happen. If, this is why I'm excited about this. Same building, demand started off at 35 kW in the middle of summer because it's air conditioning driven. Heat pumps are on the right, so now it's a winter peak, but it is 30% lower. Those are the kind of results we want. All right, what are we actually talking about here? There's 4 key elements. One, you're going to use really high efficiency heat or energy recovery. That is a key. You're going to use high performance heating and cooling. As I said, you're going to fully separate the heating and cooling from the ventilation. And you are going to right size these. You're not just going to replace what's on the roof. Typically, we've been reducing systems by 30 to 50% tonnage. And I want to emphasize this is a systems approach. So you don't get to pick one of these. You got to do it all. A lot of people now with electrification, they just want to put in a heat pump and call it good. But as I said before, even in that like for like, so let's say you took a gas pack off the roof and put a heat pump on, you're still not really solving the bigger problems of the system. It is a system. And yes, you'll get better equipment savings, but your overall system savings won't be that good unless you deal with the whole system. So heat pumps by themselves are not going to get you there. You got to do more than that. So what is this thing? Actually, it is a technical specification. It's available on our website, and it is not a specific product or technology. There are many companies that can provide products that will meet the spec. I do want to talk for a minute about heat recovery ventilation, in case some people are not familiar with it. I'm just going to do the very basics. So in a typical building, actually, before I even get there, in a typical building, usually you bring your ventilation air in, and then it either goes out through the windows or through cracks in the building or just through an exhaust stack. And all the money you spent on heating or cooling that air just goes away. And then you have to heat up or cool down more air. It is a kind of dumb idea if you think about it. So heat recovery ventilation is this idea where you take the stale air inside and it goes out the top. Then you bring fresh indoor air in, but the critical point is in the middle of this unit, you've got a heat exchanger and you are passing those air streams over each other. And by doing that, you can recover a very large amount of the energy that you put into that air. I'm going to give you an example of this. So these are 2 identical buildings. This is sort of emphasizing the importance of the efficiency of these units. Two identical buildings, you can see in the middle of the buildings, you're trying to keep them at 70 degrees and it's 40 degrees outside. On the left, if you recover 70% of the energy with your heat recovery unit, that'll deliver 59.5-degree air. On the right side, if it's 15% more efficient, so 70 to 85%, that will deliver 65.5-degree air. And you're probably thinking, well, 15% difference in efficiency, how big a deal is that? Well, it's a huge deal because the difference in those temperatures from 59.5 degrees to 70 is 10.5 degrees. From 65.5 degrees to 70 is only 4.5. So you only need half the amount of energy to keep that building warm with the higher efficiency unit. And that's why our specification requires extremely high efficiency. So it's a big deal. Now we're going to talk about, is this a panacea? I wish I could say it was, and it applies everywhere, and you just stick it in and you're done and you save all that energy. It's really good. It's not quite that good. So the first important thing to know is, as I've been emphasizing, these are systems. So we are talking about a total system replacement. That is an HVAC system replacement. So it's not necessarily an entire building. You can do it zone by zone. That might be floor by floor. That might be section by section. But you can't just like take off one piece of equipment and put another one on and say that you're doing VHE HVAC. So, these tend to be larger projects where you're doing the whole system, and it's a relatively easy call. If you have, again, if you have a bunch of rooftop units and they're all 20 years old and they're all failing, that's easy. When you've been replacing them one by one, over the years, and they're all different vintages, that's a little harder. So that's probably the most important thing. Then we don't really care about the pre-existing system because we're going to replace the whole thing, right? So you've got a boiler, rooftop units, unitary systems, it doesn't really matter. You're either going to remove them or decommission them. This next one's important. As I said, when you're doing heat recovery ventilation, the way you recover the energy is by crossing the exhaust airstream over the incoming airstream. In order to do that, you've got to have some way to move that air towards, the exhaust air towards the incoming air, which means you need ducting of some sort. So if you've already got rooftop units, you're probably good because we can repurpose the existing ductwork for ventilation. If you have a boiler, from our perspective, the worst scenario is a boiler and window air conditioners and no ventilation system at all. Technically, it's not a problem. You can always install ductwork. The reality is it gets very expensive. So just something to keep in mind. Typically, the easy installations are low to mid-rise. We can do high-rise, but they have to be either zoned floor by floor, every 2 or 3 floors by 2 or 3 floors. We don't have a solution, for a 30-story high-rise that's got a chiller and boiler in the basement and one loop that serves the whole building. If that's about to die and you want to try a whole new system, we can work with you. And it works, this last bullet, it works in what I call all normal normal commercial buildings, retail, office, schools, all fine. Okay, you want to know how much it costs. It's an extremely difficult question to answer because any of you have been involved in the HVAC industry, even as a buyer or spec person in the last 3 years, knows it is an incredible mess. Prices have gone way up for everything, not just this. And good luck getting a rooftop unit in the next year or so. The supply chains are still a disaster. These photos just emphasize what I said before. The systems are much smaller, but the equipment is more expensive. So the other good thing on the cost side is You don't need an electrical service upgrade. So if you're talking electrification, that can kill a lot of projects if you have to spend money on that. And as I showed in the results, the utility demands the demand charge on your bill is actually going to go down. So you don't have to worry about that for operational expenses afterwards. This is an example, and I'm just going to preface this by saying it's a really good example. It's that office building I was talking about. They originally went out for a bid for like replacement, $1.7 million. They came back about $2 million for the VHE HVAC. And you can see if you jump to the bottom bullet, they saved $150,000 the first year. So it was a 2-year payback, even without that nice utility rebate. What I will tell you though, I'd say this is the best case example. What we're seeing is about a 30% cost premium over sort of standard, units that you'd put in, rooftop units or whatever, which is a change, but the energy savings are probably quadruple what you're going to get doing those normal systems. And the markets, I wish I could give you better information, just we are seeing stuff all over the map. So I can't give you a whole lot more information than what I just gave you. These systems are not inexpensive, but the savings are very, very large, and the incremental cost will pay for itself relatively quickly, probably 2 or 3, 4 years. All right, I'm going to kind of gloss over this, but if you're in a situation where you or your clients want to meet sustainability goals and you're saying, well, you should try this new HVAC stuff, and they say, well, why don't we just meet RECs? Why don't we just use RECs instead? It's way easier. We don't have to do anything to our building. Well, that's the problem, right? Is it doesn't really help your building any. And CFOs don't like RECs because they don't add any value to the portfolio. It's a cost that you incur every year or every couple of years. You have to buy them over and over. They don't do anything to improve the comfort of the building, or you have your occupants have better air. They're just a little piece of paper. So you can decide on that, separately, but we think at a minimum, what you should do is VHE HVAC first, get your energy use way down, then buy RECs afterwards. This is another one. I'm not going to go into detail. I'm just going to say I am not living on a cloud somewhere or in an ivory tower. I am extremely aware of all the challenges in doing any large HVAC project, let alone one that's a little bit different than what people are used to. So this is just a partial list of all the problems that you all face every single day. And all I can say is we can do these projects. And again, if you want to meet aggressive goals, you don't actually have a lot of choice because the other options are not going to get you there. One thing I do want to emphasize is the equipment needed to meet the spec is commercially available nationwide, and it's just heat pumps and heat recovery ventilation. Industry professionals are familiar with it. They're just not used to the levels of efficiency we're talking about, and in particular, the configuration that gives us the results we're looking for. All right. IMT itself can offer you some assistance. The ComEd pilot is now closed, so we can't do any more buildings through that, though you'll see the results, like I said, in the near future. But IMT as its own organization is happy to work with you if you have a potential demonstration site. We can do some savings analysis. We can work with your engineers. We are not design engineers. We're not engineers of record, but we are happy to work with your engineers and explain the concept to them and then review their designs and make sure they meet the spec. And then happy to write up case studies and present it wherever we go. Okay, I think that's all for me. So now I'm going to turn it over to Jamie Johnson, who's going to tell you about one of these ComEd projects that was recently completed. Jamie, it's all yours, and just let me know when you want me to shift slides.
Okay, sounds good, David. And we've done this a few times, so hopefully our rhythm will be good on the slide changes. But thank you, David. Thanks, Illinois Green Alliance, for the opportunity. Thanks for ComEd for funding a good portion of this first project and hopefully setting the future incentives in a strong way that can help support a lot of this technology. I was a firefighter for 10 years in the suburbs of Chicago. Prior to that time, I've always been an environmentalist at the fire station. There was pickup truck, my bike parked, pickup truck. So I was always kind of around peg in a square hole. I started my company 13 years ago, and as David kind of mentioned, predominantly a lot of the environmental work we've done for our customers have been lighting. And I've known for some time that the lighting, it won't, is it 5 years, 10 years, or 2 years? At some point, there won't be fluorescent, HID lights to convert. And we've done a lot of HVAC work in our time, and it is very much as David describes. It's taking a box that heats and cools off and putting a slightly more efficient version of that one. And the one thing I wanted to highlight is when economizers are bringing outside air, David talked about 70% or 85% efficient. You could put demand control on outside ventilation, but you're still bringing in 0% efficient. There's 0% efficiency on the air coming in. So I really want to talk about this project, Oak Park Temple. They were an inspiring organization to work with, where they saw the vision of the importance of this. I will always remember when we did our first round of lighting work with them back in 2020. It was early COVID. Everyone's worked from home. My kids weren't in school. Our office was essentially shut down, but they had to reschedule their install because they had a homeless shelter going on at the time. So it's a very dynamically used building. There's a lot of people in this building. There can be 900, there could be 2. And it could be within the same day. There's a school, there's an office, a lot of staffing, there's a lot of people employed by this building. So it's a very interesting building. And as I mentioned, what really there's 2 things in my opinion that drove this project, and I don't represent the temple, so I can't speak for but what I understand is they had old systems that were on their last leg. And then ComEd provided an incentive to help pay for a lot of the capital changeover to this new equipment. So when those 2 things came together, they said yes. David, we can move to the next slide.
Sorry about that.
No, it's okay. So I like this picture. This is after our install. This is the main community hall to the left, and to the right is the sanctuary. There's a divider that goes down the middle that's currently open right now. And there's very tall ceilings, 20-foot ceilings. There's a huge glass to the left you can see that in cold weather, you can feel the cold weather coming through that wall. So it's an old building. It's got a lot of history. And it's got a very difficult building to retrofit. I've always been challenged by all the suppliers and David and anybody else who talks about this project that we picked the hardest project to start on. So the next one's going to be a cakewalk. So I hope that's true. But you can see in this space, there can be a lot of people in this space. Sorry, you were right on, David. You can keep going. To the left of this is the school, and to the right is this beautiful rotunda area. The rotunda area has a lot of meetings, a lot of services, a lot of events, very dynamically used, but it's also very beautiful. It was an architectural challenge to retrofit. The engineers said to do one thing, we actually modified it and did differently because we didn't want to change the way the space looked. And I think in the end, we actually made a better performing system by some of the changes we made. To the left is the school. And one of the things that really struck me about this building was during COVID, in order to stay open, there's a preschool, there's about 20 classrooms. Not all of them are occupied, but they are used 6 to 7 days a week. They had to leave their windows open year round, winter, cold, polar vortex, 100-degree days. They had to leave 2 windows open in each classroom to have adequate ventilation to meet the needs for the state to remain open, because there was 0 outside air coming into the school. There was very limited outside air coming into to the main sanctuary area, community center that we saw earlier. I would argue there was none, but it was an old design system that was not, there had not been a lot of investment to focus on quality air coming into the space, which is very normal and is what every building, anyone who's been on a roof and has seen an economizer with cardboard over it, because that's the way technicians sometimes solve problems when things are underperforming, knows that outside air was not a focus pre-COVID, other than code and permit. I'm not gonna say for all, but that's been my experience with most commercial clients. So cold air coming in, kids in their jackets, no fresh air from the outside. So in a learning environment, just a lot of challenges. You can move on to the next slide. So there was the two things I've shown so far were a lot of the original building. There was also about 23 years ago, a new wing added that included office space, administrative space, a library, some meeting space, and that was all controlled by 20-year-old RTUs. I think only one of them had been updated. So some old RTUs that were mostly still working. I did find out the last fall, one of them definitely wasn't working, but you know, we learned as we went throughout that there was a patchwork of work. And then in the original design, what's called a pump and dump cool water system. So water would come in from the city, the compressors would work, and instead of evacuating the air through the heat through the air, it was the city water was taking the heat away. These are now illegal. If you think of the environmental impact of treating water and then treating the sewage after water runs into the system, like it was an environmental disaster, and that's why they've been outlawed. But it is those systems were performing well, but definitely on their last legs. And I mentioned that, you know, I don't have data, but there was very little outside air pressure getting into the big community space. There was very little outside air coming into the school, except when the windows are open. And they had some old boilers also to do heating. And so we had a key technician from there. You know, one company had maintained this system for at least 10 years, probably longer. And the main owner of that business was transitioning and retiring, and the temple had to face the fact that they were going to have to A, replace a lot of the equipment in piecemeal, and B, find someone to service it. And it was a big challenge for them. Next slide, please. So we found a commitment to this project in late 21. And if, you know, just to put in everyone's mindset, I think there was some concerns about inflation starting to peak up, some concerns definitely around supply chains, but nothing was really discovered until I would say the next few months. We started to see significant HVAC display delays on equipment we had ordered for other owner operators of McDonald's. We do a lot of HVAC RTU replacements for them with high efficiency. Some of them we ordered around this time this project started, and some of them were just installed recently. So David's notes about delays about rooftop units was real. And the pricing obviously started, you know, with to budget. We'll talk a little bit more about the budget, but budgeting was very difficult. I've found that as I've looked at least 15 projects since this one, to provide an accurate budget without starting to spend money on engineering is very difficult. I'm starting to get a better feel of how to proceed. We can do some general square footage budgets, which I think will be more stable in the next 5 years than they were in the last 2. But I also think there's other retrofitting. These systems, heat pumps and VRFs, are very common in new construction. Retrofitting is not common. It's challenging. And as we'll go through, we experience all these challenges on this project. But it's a great project. The system's performing very well. We're making tweaks to try to learn more about the data. We didn't have great original plans for this building, which is very common. There is, I think there's 20 pages and half of them have like coffee spills on them. So there wasn't a lot of really good data. So going into this project was a challenge because of budget, supply chain, pricing, as well as engineering. Next slide, please. I personally, in a retrofit, think of things in 3 phases. Phase 1 is engineering. So you started to spend money on engineering. Engineering could cost $20,000. It could cost $120,000. but it's not inexpensive. Phase 2 is ordering the major equipment because it's hard to start without having that cassette on that. It's hard to have all of the small wires, the communication wires, all of the hanging equipment in your warehouse, and then you have 6 months to a year before this cassette comes in. So I believe ordering the major equipment first. That's the major source of cost on a project like this, at least in terms of material. And then phase 3 is the installation of all the systems. In an open building that's closed, this could be a fairly simple process. On a project that is, you're doing this while the building is occupied, as we did, it's tricky. And I didn't note a little bit before, but we had to decommission or turn off some of the heating equipment in order to install some of the VRF systems and some of the ductwork for this ERV system. So the rooftop units were easy. We waited until everything was done, and then we had the crane come in and take those off and put in the ERVs. That was easy. But keeping the system heated with the boiler was very challenging, especially because demolition of that old equipment was a key component of this project. Next slide, David. So keeping a building that's dynamically used with a lot of different constituents, including a school, religious organization, homeless shelter, a lot of community coming together, working through a major construction project in a building that ended up having asbestos, that had a lot of, David noted that it's easy if ductwork exists. Half the building had ductwork, the other half did not. We had to core holes through 15 inches of concrete, where we found embedded steel and embedded electrical that was not in the plans and kind of didn't make any sense. We even paid extra money to have someone come out with an ultrasonic machine and test for steel, did not find it. Coring, we found it slowed everything down and created just a lot of obstacles. During the 1 month we had this building basically vacant to do a little bit of work in the school. So trying to do all of this was challenging, and I've talked about the challenges enough, and I'm always happy to talk offline with anyone about the challenges we face. But I would say for me and my organization, what we learned, we focused on reacting to the problems, which I think was appropriate. We forgot to consistently inspire the community that we were doing the work in and why we were doing it. We're going to have fresh air for the first time in the building, potentially ever. We're going to save costs. You're going to get a system that works. We're stopping boiler leaks. There were some real benefits that I think with a more systemic approach in making that a more part of the project, I think it would have made it easier for everyone to go through the pain that is inevitable with construction. Next slide, please. When we started this project, we budgeted at $30 a square foot, which was felt fair based on feedback we got from multiple organizations back in late 2021. Of course, I mentioned asbestos abatement. That was significant cost and a surprise. I also mentioned coring through concrete, taking out electrical, finding a steel beam inside the concrete. So there was surprises that I didn't bake enough of that into the budget in the beginning. We ended up actually around $50 a square foot, which is consistent with what we're finding other contractors bid on. We did not employ a general contractor. We acted like it. Next time, I think bringing in as many partners as we did, there was probably up to 17 different subcontractors doing different parts. I think a GC is an important consideration. I personally did not fire underperforming subcontractors quickly enough. I did in the end. But the delays that one of the subs provided, it literally took me sitting there for a week doing that. I just set my home office outside of where they were doing the work. And after about 2 days, I realized they were not going to be able to do the job they kept committing to. So this picture shows horizontal ventilation. I won't dwell on this, but some contractors are confident on horizontal. Some vertical would rely on a more detailed engineering of the curb adapter to adapt all the incoming ductwork, and it would force the unit to sit a little bit higher. But after this experience, especially how it impacts the roof, I do believe vertical ventilation would be more important with the Ventacity ERV system. Next slide, please. So I love this picture. This is a picture of the roof for anyone that'll come to the tour today. It to the left is a picture of the school roof. The 4 beige units are the outdoor compressors. 2 of them feed the first floor, and 2 of them feed the basement, or 2 of them feed the top floor, and 2 of them feed the bottom floor. The 2 that work as a system together. To the right is the Ventacity 3000 CFM units, as well as the ductwork that we put in to go into the school. And to the right is a picture of the indoor fan coil unit. So as a system, the outdoor compressors on the left take refrigerant and they change state and they move it through, refrigeration lines, which are copper, into the building, into these cassettes where they change state again, either releasing heat or absorbing heat, providing cooling. But these are 2, as David has highlighted, these are 2 systems. One is fresh air with energy recovery to maintain to maintain the temperature of the air coming back in, and the other one is a heat pump, variable refrigerant flow heat pump system. 2 systems, and the VRF system has outdoor components with indoor components that work as a system. Next slide, please. So you can see, natural gas, you can see it's not gone to zero. We did have 1 rooftop unit left running for the rotunda through the winter. So that small spike, about 1,000 therms, is a portion of it is that. They do also have a commercial kitchen and several hot water heaters, which we have not electrified yet. Yeah, would be the key word there. But you could see, the reduction. 7,000 therms at $1.30 or whatever we were at in December is $9,000 to $10,000 a month. It would range because December was a pretty cold month in Chicago. But this is a significant, you cannot decarbonize heating without removing natural gas from the picture. And we did that in this building. Next slide, please. And just to talk about troubleshooting, I could spend the next 3 hours talking about, thanks, David, the things that we've learned on this project. The things that we, even as early as late last week, we went out and we moved to thermostat. I believe a server behind a wall was creating heat, which was overcooling and making it uncomfortable for the staff in the summer. The timing of how we did things, that one of the projects I believe is held up by a 600 amp service panel. Our panel came in 4 days before this project went live. Like, it landed in the thing and it was installed like 3 days later, which was dependent on the crane lift. So building in more cushion time was something I would do. Programming these systems are very complicated. I believe that this system has been fighting a little bit heating and a little bit cooling. I believe that not because I believe it, but because the engineers have looked at the data and have provided some support supporting that. And so we've adjusted how the system is programmed, hopefully in the end, getting to a place that's using much less energy. I think that covers that, David, unless you want to know anything else. So what do we do this again? This slideshow that we just went through represents the hardest year of my life. It was a huge project at a very difficult time. And yes, I'll do it again in a heartbeat. The system works, provides fresh air, it heats and cools. I was in the sanctuary on December 23rd when it was -10 in the morning, and it rose all the way up to -5, I think, by the time they had a service, and the building was warm and toasty. The system was performing. And so this works. I've been told by a million people that this system wouldn't work. It doesn't work north of the Mason-Dixon line. I've heard this would be a $5 million project. One contractor didn't show up. The next day, a contractor showed up and he said, it's a $5 million project, and walked out. So the world, Chicago, and our state, our ecosystem needs this work to get done for a lot of reasons. It doesn't have to be as complicated as this project, but we need this technology to hit some of the goals like David talked about, but frankly, just to kind of weather the storm that's coming for us. So I appreciate everyone listening, and I appreciate the opportunity I've taken on this project. I appreciate that IMT showed me this concept 2 years ago, and that the building and our team was able to make this happen.
Thank you so much, Jamie, David. This was fantastic. So we have about 12 minutes till 1 o'clock. So we've gotten a few questions in the chat. If you have any more, please add them and we'll go through them. The one we have right now is, and I'm not, David and Jamie can decide who to answer this. How much of the energy savings of VHE HVAC is just from the right sizing? And what if you added weatherization?
I'll take that. So in terms of weatherization, it's, there's a ideal sequence that you would do any energy efficiency project at the building level. And that is, you start with the envelope and then you do the other systems. Honestly, I used to talk about it like that. And I've been doing energy efficiency work for a very long time, and I'm a true believer in that approach. The reality is that envelope work and windows are incredibly expensive, and they just don't get done very often for economic reasons. All of the results I showed you in that earlier slide, or I will say, I think in 10 or so of the 12, nothing else was done to the building. And then there were a couple where there were minor ones. What happens is, if you do the HVAC first, you have to size it for whatever the building is. So it's going to be slightly oversized relative to having done the envelope, the upgrades on the envelope. But I don't know, it's just a practical question. If the client says they're going to do the envelope, then downsize the system even more. If they're not, again, we're downsizing these systems 30 to 50% even as is. And how much of this actual savings come from right sizing? I can't answer that directly, but I'd say some, but it's really the combination of the components that I described that give you these big savings. I mean, if you take a normal like rooftop unit and replace it with a right-sized one, saying it was oversized, you get some savings, but you're not getting 70%. You're not even remotely getting 70%. So that's my answer for that.
I'll chime in from my perspective too, and I would say, maybe something that's important that we didn't talk about is engineers are, from my experience, a little bit nervous to design some of these aggressively. So I believe, when I talk to clients about their pain points, if they have an old boiler that needs to get replaced, if they don't have control over the temperature in different spaces, these systems will give you that. So I believe you would find more cost reductions on the project by being able to size it lower, having done other systems, because you're not going to need as much electrical capacity for each compressor. You're not going to need, those things will get smaller, which will reduce costs for the install. But you're still going to have to bear the cost of doing the envelope, which is, as David mentioned, very sizable.
And actually, I'm just going to throw in one of the other projects we're doing through the ComEd program is a building, and it's only 25,000 square feet, I believe. And they are replacing the windows, and we are taking that into consideration in the calculations, but they're spending $1 million just on the windows, just to put this stuff into perspective.
Wow. Thank you so much, David and Jamie. Next question. Did this VFR system include a branch selector box?
So it did. We had 6 systems in this temple. We ended up going with Daikin. We looked at Daikin and Mitsubishi. We went with Daikin because of a lower cost on the initial project. I do think in hindsight, the cost probably would have been pretty on par when you account for, I'll discuss something about the branch selector box, but the branch selector boxes worked on systems that used energy recovery, or heat recovery. So, for example, in the sanctuary, it is very unlikely that you're going to have heating and cooling at the same time on the same system. So there would not be an opportunity, and this I learned from the engineers through IMT that supported us on this. Energy recovery and branch selector boxes where you can take heat from one room and transfer it to another room without having to use the compressor on the rooftop. Big energy saving opportunity, but not applicable to every room or every space or every building. So I believe the school has it, and definitely you can see a space in October when the heat is coming in on one side from the sun, it's cold on the other side, and so without running the compressor, we can, through the branch selector box, transfer heat over. The admin area, we did have a branch selector box, and for the tour today, this will make a little more sense. The first floor school, but we did not in the rotunda, we did not in a small system that's to the outside of the sanctuary community hall. So the big trick that I learned about this is when you add that system, some of the systems require three pipes, and that third pipe, when you're talking about thousands of feet of refrigeration copper line, and copper that was, it's not anymore, but was at an all-time high a year ago, that can add to not just the material cost, but also to the labor of brazing each of those pipes together and maintaining the standard of brazing that you have to avoid refrigeration leaks.
Great, thank you. Another question that I personally had was, we have been hearing a lot of issues with workforce, with contractors, and the issue of getting the workforce trained up as we start using different and newer systems and newer technologies. It seems like you had those challenges here. And so I was curious if for the next time, what are the lessons learned when it comes to working with contractors that aren't used to these technologies? Is that just a part of the process right now as we're all learning, or do you think there's ways to try to work with that?
I mean, I think Chicago's got great trades folks. So like we've got the labor force. There's a lot of new construction going on with walk-in coolers and freezers. So people know how to braze copper lines. It's we've got a lot of electricians. There is some advanced communication that needs to go in these systems. But none of it is like rocket science in terms of nothing is being done that wasn't done the last 50 years. And David, you might have a different opinion on this, but like it is changing the thinking and doing it in a different way. And personally, I believe that's more at the top leadership of small contractors. I think that there's several contractors that are very aggressive, and I've seen them in other webinars like this, and they're dominating this space, but the rest are kind of ignoring it, heard a horror story, did one, had a bad experience, and so the ownership is pulling away. So I think it's for me, it's the leadership of small contractors and large contractors that needs to get behind this.
Yeah, and I'll just say, having spent the last almost 3 years trying to get people to adopt the system, owners tend to be enthusiastic if they're even talking to us, right? They're only talking to us because they want to do something and meet some target they've got. And then they turn you over to their engineers, and we've had a big range, but like Jamie said, they just get nervous. You say, look, we can do this with 40% less tonnage. And they're like, and I have to sign my name to that. I don't know about that. I've never done this before. It's not that they don't get the concept, but they just don't believe it bluntly. And that is exactly why we're doing these demonstration projects. That's why we're so thrilled when utilities like ComEd are willing to fund them, because at the end of the day, it's not just any demonstration project. People won't believe it unless it's in their hometown or close by, same climate zone. It's like, well, they did it in that blue building, but mine's green. I don't know if it'll work in a green building. I mean, the level of nervousness is pretty high, but I understand it. These are big investments, right? So, but it's tough. Like Jamie said, somehow we've got to shift the industry if we want to get where we want to get. And it's an uphill battle.
Awesome. Well, thank you so much. Thank you for everyone for joining us today. And thanks again for the speakers, David and Jamie. Like stated earlier, all attendees will receive a PDF of the slide deck, recording of the session, and additional resources about today's topic, VHE HVAC. Also, we're excited to see Jamie as well as Steve Labarge from ComEd at the tour this afternoon at 4 o'clock sharp. Please be there by 4 o'clock. That's definitely when we'll start in Oak Park if you want to come see some of this stuff yourself. We are dropping the link in the chat now. We still have openings for the tour. If anyone wants to sign up last minute, we're welcome for it, and we're excited to see everyone later. Thank you all so much.
Thank
Bye.
you.